sector contributes to global carbon emissions through two main avenues. Water and wastewater utilities consume energy during their conveyance operations and their treatment operations. Greenhouse gases are produced as the result of the wastewater treatment processes, usually in the form of nitrous oxide and methane. Globally, the water sector accounts for about 10% of the total greenhouse gas emissions. But with the rapidly growing water demand, the sector will be driven to more energy-intensive treatment processes and water sharing to manage the water supply. Coupled with the impacts of climate change, droughts, and damaged water infrastructure from extreme events, this puts us in a fragile position to provide water. It is important for the water sector to get behind decarbonization now so we can be water secure in the future.
We're really excited to see that wastewater and water utilities are really getting proactive, and they're really becoming trailblazers on the path to reach net zero emissions. And what's important is that they're really creating a playbook for utilities to, get going on their decarbonization path and providing a lot of those helpful components to kind of get going.
So the 2030 Breakthrough Initiative is one that has been set by the high-level climate champions. It's informed by the best available science and in full knowledge of what the sector has to deliver. Ultimately, what we're aiming for here is for the largest utilities responsible for 20% of global water supply to fully decarbonise across their entire business by 2030. But the water sector's impact on global emissions is really quite large and often surprising to many. It is in fact the equivalent of the entire shipping sector put together. This is a result of the fact that they consume a huge amount of energy in the way in which they use and treat water, and in fact, of course, the way in which they pump it around to our homes, farms and factories. At the same time, there's a huge amount of energy that goes into treating our wastewater. So some of the major challenges that are facing the sector in terms of decarbonising by the time we need it to is the fact that many of their customers aren't necessarily demanding it of them at this stage. And that is an important opportunity that we need to unlock in the coming decade if we are ultimately to trigger the transformation needed within the sector. Technologies exist to enable the sector to do so. They need to harness that. There needs to be a will within the leadership of all of these companies in order to take advantage of the opportunities that are facing them and invest as wisely as possible.
My name is Mads Let. I'm the CEO of the utility VCS Denmark. VCS is located in Odense, in the middle of Denmark. Odense is the third largest city in Denmark. Well, 10 years ago we decided to embark on an energy optimization program. It was a natural progression of our work on optimizing wastewater treatment. So we wanted to take it to the next level.
My name is Per Nielsen. I'm a project director here in VCS. My role in the company is to support and together with my good colleagues to develop new technologies and take VCS further in this journey we have embarked on. Here in VCS we have a Beyond Energy Neutrality program, and we have been working on this for the past more than 10 years. We started out in 2010 and trying to become energy neutral. We were very good at that time. We were already 76% energy neutral, but we thought it would be possible to do more. Many of our colleagues were talking about doing that in 10 years' time, but we thought, let's do it in 4 years' time. So we set a high goal for ourselves and to become energy neutral at this wastewater treatment plant within 4 years, and we achieved that.
So through this work we support our local municipality in a general green transformation. We are a heavy energy consumer, but wastewater treatment plants also offers the option of energy production, which is very important in the green transformation. So being a heavy energy consumer, we wanted to switch that approach to also focusing on energy reduction, but also energy production.
Adaptation of new technologies is a key factor in this. You have to be bold to be able to go down this journey. It's important to look at new technologies and new approaches. The next step for us is more focused on methane emission. Fugitive methane emission is a problem, and it's just been addressed by the UN as a growing problem. The same with the nitrous oxide is a problem that we need to address and have a goal for how we can reduce that. Denmark is on the forefront of that by introducing a taxation system on nitrous oxide, and that will force the wastewater industry to develop new technologies to minimize the greenhouse gas emissions.
In the future, I see wastewater treatment plants as energy providers. We are net energy positive, meaning we sell energy to the public grid in the local municipality, both electricity and heat to the district heating system. And the technologies we have implemented are not new. We have simply changed the mindset in operating the wastewater treatment plant. So virtually all wastewater treatment plants in Denmark and in the rest of the world should be able to follow this path on becoming energy neutral. In general, playing a significant role in that green transformation of our society.
Hello, my name is Adam Hosking. I'm Jacob's Global Director for Water Resources and Resilience Solutions. Globally, we've also seen an increase in water utilities achieving emission reductions by building on-site renewable energy projects. This is exciting because it points to how the water sector is really committing to the decarbonisation agenda. But for some countries, this is a huge challenge. Increasing populations means a reduction in land space, which reduces the possibility of building such large developments. And even if land isn't an issue, some parts of the world struggle in terms of their access to renewable energy resources because of their geographic and climatic conditions. So the question then becomes, what can water utilities do to support net zero emissions when they're faced with these limitations?
I'm Chimeng, and I'm the Chief Engineering and Technology Officer at PUB. I lead PUB's research and development program to develop and deploy new water technologies applicable to the entire water cycle. PUB is Singapore's national water agency, which manages the country's water supply, water catchment, and used water in an integrated manner. Recently, we also took on the role of coastal protection and are tasked with protecting Singapore's coastline from sea level rise. As we grapple with the challenges of climate change, it is imperative that we ensure Singapore's water supply remains resilient but also sustainable. Over the last few decades, PUB has diversified Singapore's water resources through its 4 national tabs strategy. Having successfully addressed the water challenge, we plan to do the same for carbon. To achieve this, we mapped out a strategy to use clean energy and to reduce the energy consumption of PUB's water treatment processes. We recently opened one of the world's largest inland floating solar farms constructed on a freshwater reservoir. This allows PUB to fully power our waterworks using green energy. With solar energy being plentiful, we hope to harness more of this limitless resource to reduce our carbon footprint. Seawater desalination is an energy-intensive process, so it is our goal to reduce its energy use by about 50% by 2025. We hope to do this through the development of ultra-permeable membranes, such as the biomimetic membrane, that mimics nature's way of extracting fresh water from seawater.
Hello, I'm Wei Hin. I'm the Director in charge of implementing the Deep Tunnel Sewage System Phase 2, or DTSS2 in short. It will convey used water in the western half of Singapore to the new Tuas Water Reclamation Plant, or Tuas WRP, for treatment and reuse. The future Tuas WRP will be equipped with advanced treatment facilities to treat domestic and industrial used water streams separately. With these advanced treatment processes, the plant will also recover more than twice the energy while occupying much less space compared to our conventional water reclamation plants. The plant will be co-located with the National Environment Agency's Integrated Waste Management Facility to form Tuas Nexus, the world's first integrated used water and waste treatment facility to be designed from the ground up. Tuas Nexus will harness 9 synergies from the treatment of used water and solid waste, allowing the byproduct of one facility to become a resource for the other facility. Tuas WRP will be powered entirely by renewable, green energy derived from solar power and the combustion of biogas, sludge and solid waste. The electricity generated by Tuas Nexus will be more than enough to sustain the operations at both facilities, with the excess being exported to Singapore's national grid. This excess electricity is expected to be able to power up to 300,000 typical apartment units in Singapore. We have also calculated that the net carbon savings from Tuas Nexus will equate to over 200,000 tons of CO2 annually, the equivalent of taking over 42,500 cars off Singapore's roads. As a part of Tuas Nexus, we are very excited to have the opportunity to create something where the sum would be far greater than its two individual parts, an innovative and sustainable solution to maximize energy and resource recovery, and establish a new international benchmark in the fields of used water treatment and urban waste management.
But the challenge now is one of reducing carbon emissions and decarbonization. Although the global water sector contributes about 5% of greenhouse gas emissions, it has not received significant attention in the climate discussions. I hope to see innovative, game-changing solutions that can meet the operational needs of water utilities, while at the same time reducing carbon emissions. For this reason, PUB will be launching an open innovation challenge this year, where we will invite researchers and companies from around the world to co-create carbon sequestration and utilization technologies that can be integrated with water treatment facilities.
Beyond reducing their own emissions and exporting energy into electricity networks, the water industry may have a larger role to play to reach net zero emissions. We've seen how water organisations are looking to the future by developing solutions that could make a much larger impact on mitigating climate change and supporting the transition to a decarbonised society.
Yes, I'm Pat McCafferty, the Managing Director of Yarra Valley Water here in Melbourne, Australia. Yes, Yarra Valley Water is a water and sanitation utility servicing the eastern and northern suburbs of Melbourne, so a population of about 2 million people. And so our purpose is to support the health and wellbeing of our customers and contribute to a brighter future for the community and the environment. So as a water utility, we're pretty significantly impacted by climate change. Certainly here in Australia, it's affecting the long-term reliability of our water supplies by reducing rainfall and ultimately stream flow into our catchments. Hydrogen was, I guess, the next big thing. It's certainly being talked about nationally in Australia as a conversation about how we can address climate change, how we can switch to renewables. But there's been a lot of, I guess, talk about hydrogen, but not so much in the way of practical implementation.
Simon Prunstar, I'm the Energy and Emissions Specialist at Yarra Valley Water. I'm responsible for the development and delivery of strategies and projects that will lead us to being 100% renewable and net zero by 2025. Hydrogen is a technically viable and ecological energy vector that has broader applications. It's suitable for heating, as a transport fuel, for blending into natural gas supply, and as a store for intermittent power generation.
In Australia, we can use hydrogen to decarbonise many parts of the economy, from us, sewage treatment processes, and pumping water and sending water to our customers, through to fuel for transport, large heavy transport and so forth. So it really has shows great promise in being a more flexible source of renewable energy.
For every 9 litres of water, you can produce 1 kilogram of hydrogen and 8 kilograms of oxygen, meaning that oxygen makes up 89% of the end product from electrolysis. If you find a value for this oxygen, instead of venting it as a waste gas, then you can subsidise the cost of producing hydrogen.
For us, it's about finding a value for that oxygen and exploring, can we reuse that oxygen back in the sewage treatment process? Hopefully we can get a lower cost sewage treatment process. Obviously cost is one thing, but we also then reduce our energy costs from taking energy from the grid, because it's on our side of the meter. So there's another operating cost reduction that we can flow on to our customers through lower bills. And of course the major outcome is more renewable energy, less use of fossil fuels, which we all benefit from, obviously. So where we're at with our hydrogen journey is that we've done the thinking. We're really getting close on finalising a business case to actually invest in a pilot hydrogen plant. That plant will be located and co-located at a sewage treatment plant. It will use renewable energy and recycled water from our sewage treatment plant and our waste to energy plant that are on the same site, which means we can produce green hydrogen. And the initial application of that hydrogen will be going to the nearby Melbourne wholesale food markets, which is a very significant operation in the north of Melbourne, which essentially is the key distribution point for all of the food for the city of Melbourne. I wrote an article, it was a little bit cheeky, but the headline I actually gave the article was, could sewage treatment plants or wastewater treatment plants be the service stations for the future? So it's conceivable, certainly for heavy transport, that, we could be producing hydrogen, and where our particular plant, our pilot plant is located, is between Melbourne and Sydney on the major road. Everyone is now in the water sector starting to really seriously think about what can we do to address climate change, what can we do to reduce our own energy footprint, our greenhouse gas production, and be part of the solution.
The water industry can lead the way in demonstrating a pathway to net zero, given our unique place in society, the assets we operate, and the people we employ. We have the opportunity to find solutions to difficult challenges that could change the world for the better. Helping to make green hydrogen a viable, renewable fuel would go a long way to demonstrating this.
Solving the Baltic Sea situation is a very important component of the race to zero. We'll be mitigating a significant amount of greenhouse gases that are generated as a result of the epoxy conditions.
Marine hypoxia is a worldwide environmental crisis. It is a condition in which the bottom of estuaries and coastal areas have no oxygen. In the Baltic Sea, because of the legacy of past pollution, the deep water has no oxygen. The Baltic Sea is actually the world's largest marine dead zone. In fact, it has gone so long with so little oxygen that there have been some conversions in the geochemistry so that the bottom of the Baltic Sea smells like a sewer. It's full of hydrogen sulfide. It's actively toxic to marine life. What is needed is a direct engineering intervention. We need to put the oxygen back in. We know how to do it.
Freshwater lakes have dead zones too. Over the past 20 years, we've learned how to inject pure oxygen deep into these lakes to eliminate dead zones. We have arrived at a level of experience where we can look at applying this to marine scales. This will scale up to any marine dead zone that we can imagine at this time. The innovation is in understanding all the elements of scaling up to marine applications. Marine scale oxygenation presents special challenges. It's not the pointy end of the stick, the dosing of the oxygen, that is a great innovation. We already know how to do that. The important thing is to integrate it with energy. At these very large scales, the question of energy becomes extremely important. We are learning how to integrate oxygenation with the production of green hydrogen via electrolysis. Oxygen is just a waste product. Instead of venting it to the atmosphere, we're understanding that we can put it deep into the water to eliminate dead zones.
We're excited to see water and wastewater utilities stepping up as leaders to reach net zero emissions. They're creating a playbook for other utilities and demonstrating the benefits of a decarbonized future. We've seen some utilities take big initial steps like switching to more efficient energy sources and capturing their greenhouse gas emissions. We're also seeing modern utilities use digital innovations to collect better data on water consumption and water conservation initiatives.
The latest IPCC report, AR6, that was released a matter of weeks ago, really hammered home the fact that if climate change is a shark, then water is its teeth. The most significant impacts of climate change will be felt through water, and therefore the transformation that we're able to deliver with the water sector that ultimately sits at the heart of this challenge is fundamental to ensuring that we thrive and succeed as a society. The call to action for utilities, particularly those from the Global South, is to join us in this race to zero. Go on to the Climate Champions website and find the link to enable you to sign up to the race to zero. The more utilities that we can get joining us in this race will send a loud resounding signal to governments that they too can be bold in terms of achieving our climate ambitions much faster than they currently believe we can do.